Hello everyone. We're going to continue now our discussion now. So let's talk about hydrostatic force on a vertical plane surface. So if we have this figure, no, just like in the previous diagram, so we have this tank, no, it was spin at at 2 points, no, and then we have the height of the liquid, and this is our free liquid surface at the top. And we consider the specific weight of the liquid, and since the tank is open, the gauge pressure measurement will be zero at the top, no? And consider now variation in pressure as we go down, no? So there is variation in pressure at the left side of this tank, no? Wherein the pressure intensifies, no, tumitindi yung pressure habang pailalim. Okay? So, tumitindi habang pailalim. So, umahaba. So, ito yung representation ng pressure, yung haba ng arrow na yan. Okay? So, sabihin yan, lumalakas ang pressure habang pailalim. Okay? Ayan. At it is now triangular yung kanyang pagbabago. Diba? It varies linearly wherein makakapag-form tayo ng triangle. Okay? So, tumitindi habang pailalim, nag-intensify yung pressure. Okay? And now, consider naman natin yung kabila, ganun din. Okay? Right side ng ating tank. As we go down, the pressure also intensifies in magnitude, no? Okay? Lumalakas ang pressure. Diba? Kasi ang alam natin, ang pressure formula ay anong ating pressure formula? Ayaw magsulat. Wait lang. So, ano yung ating pressure formula? Unit weight times the altitude if the pressure at the top is 0. No? Okay. So, sabihin yan, so kung ito ay H1, kumpara natin dito, H2, okay, then dito H3, okay, so ang pressure dito, acting at this side of the tank, ay hindi katulad nito, acting at this side of the tank, hindi rin katulad nito, acting at this side of the tank, no? So, at a certain part of the tank, no? Yung kanyang sa left side. So, ganun din, no? Triangular, yung kanyang pagbabago. Okay? So, triangular. Okay? And then, consider natin na the pressure at the bottom of the tank ay equal sa unit weight times the altitude. Okay? So, ganun din dito sa kabila. Ngayon, take note that at this point, We call this as the center of pressure. CP, center of pressure. It is where the force is acting. Okay? It is where the force is acting. The hydrostatic force is acting. Okay? So, ganun din sa kabila. Okay? So, the hydrostatic force is also acting. So, this is the pressure distribution. Okay? So, yung distribution of pressure ay hindi constant. Okay? So, hindi constant yung distribution ng pressure. Okay? The pressure intensifies as we go down. No? So, in this case, triangle yung kanyang uh, form, no? Yung pressure distribution natin. Triangle form. Yung kanina, uniform pressure, rectangular form. Dito, triangular form. Okay? So, pressure distribution and hydrostatic force on the ends of an open tank. So, at the ends of the open tank, there are hydrostatic forces at the ends, no? Okay. Now, so we consider this part. Now we have the plane surface. Considering the left side view of the tank, no, yung left side view, wherein the force is acting, ito yung area sa left, wherein the hydrostatic force is acting. Okay? Itong area na yan. Itong dito. Siyempre, ganyan yan, di ba? So, this is where the force is acting actually, no? Yung actual location ng F dito talaga. Okay, yan. Ito yung area na yan. Ito yung area na yan. Ayun. Yung left side view, no? Ng tank. Okay? So, this plane surface is considered. So, this is the left side view, and this area is where the hydrostatic force is acting. Considering the center of pressure where the hydrostatic force is acting. Considering also the centroid of the plane surface. Yung centroid ng plane surface. No? Centroid ng rectangle. Ito yan. So, iba ang center of pressure, iba ang centroid. Take note. No? Iba ang centroid sa center of pressure. Okay? Ito ay triangle, di ba? Kumbaga, ito yung centroid ng yung center of pressure na yan, yun ang centroid ng triangle diagram ng pressure, no? Pressure distribution ng yung pressure distribution, no? Triangular pressure distribution. Okay? So kung triangle yan, okay, this is 1/3 and this is 2/3. No? Okay? 1/3 dito, 2/3 doon. Kaya, nandito yung center of pressure. No? Dito sa centroid, 1/2, 1/2. Okay? Okay? 1/2, 1/2. So, we continue. So, we consider now the distance between the centroid and the center of pressure. So, that is the eccentricity. So, ang tawag natin dito ay eccentricity, which is a distance between the centroid and the center of pressure. The centroid of the area and the center of pressure. Okay? So, yung distance na yan, that is eccentricity. No? So, next, so yung pagkuha niyan, yung formula, yung eccentricity, ay equals sa moment of inertia about the x-axis. No? Yung na-introduce ko kanina, yung moment of inertia. Moment of inertia about the x-axis. Okay? All over HCA. Ano yung HC? Ito yun. No? So, yung HC ay yung vertical distance. Ito yung HC. Vertical distance from the free liquid surface down to the centroid of the plane area. No? So, and then area of the plane surface. No? Area of this plane surface. Itong E na yan. So, yung E natin ay eccentricity. The distance between the centroid and the center of pressure. Okay? So, next, we have, so ito yun, yung HC natin, no? Then, meron tayo ditong HCP, no? So, ito yung vertical distance from the free liquid surface down to the center of pressure, no? Yung vertical distance na yan, HCP, no? From the free liquid surface to the center of pressure. Okay, wherein HCP, okay, ay equal sa HC plus E. No? HC plus E equals HCP. No? So, the vertical distance from the free liquid surface to the centroid of the plane area plus the eccentricity will give us the vertical distance from the free liquid surface to the center of pressure. No? So, HCP equals HC plus E. And then, the hydrostatic force acting at the plane area at this plane surface can be solved by multiplying the pressure at the centroid. Dito. The pressure sa centroid. I-multiply natin sa area ng ating plane surface. Will give us the hydrostatic force. No? Acting at this plane surface. Okay? Wherein the pressure at the centroid can be obtained by multiplying the specific weight of the liquid and the height, no? From the free liquid surface down to the centroid, no? Or tawagin natin pressure head from the free liquid surface to the centroid, no? So we can now proceed. So therefore, since PC equals to specific weight times HC, no? So F now is equals to specific weight times HC times area. Diba? So take note C yung centroid, CP is the center of pressure. Okay? So let's solve a problem, no? So here's the problem. We have a vertical rectangular gate, 1.5 meter wide and 3 meters high, is submerged in water with its top edge 2 meters below the water surface. Find the pressure acting on the centroid of one side of the gate and its location from the bottom. Find also the hydrostatic force acting on the gate and the location of it from the bottom. So let us analyze. So here's the vertical rectangular gate. Okay? So it is 1.5 meter wide, no? Ito ay sabihin natin ito yung front view. Ito yung right side view, no? Front view, right side view. Okay? So yung kanyang right side view ay ito. Okay? So this is 1.5 meter wide. Okay? And 3 meter high. Okay? Is submerged in water. Na-submerge siya sa water. So sabihin natin, ito ay lupa, ano? Tapos lupa din ito. Okay? And ito, na-submerge siya sa water. Okay? So meron water sa left, it was submerged. Okay? So nakalubog sa tubig. Okay? Yung area na to. Yung area na to naka-expose sa tubig. Okay? So it is submerged in water with its top edge 2 meters below the water surface. So ito yung kanyang with its top edge 2 meters below the water surface. So ito yon yung kanyang top edge dito niya with its top edge 2 meters below the water surface. Okay? Ayan. 2 meters below the water surface. So find the pressure acting on the centroid of one side of the gate. So kukunin natin yung pressure acting on the centroid of one side of the gate. So pressure, ito, the pressure acting on the centroid, ito. Ito yung one side of the gate, yung right side view ng gate, diba? One side of the gate, yung right side view niya. So find the pressure acting on the centroid of one side of the gate and its location from the bottom. So mula dito, okay, so we have the centroid. Okay, this is the centroid, and we were to find the pressure at the centroid. No? Find the pressure acting on the centroid of one side of the gate, no? And the location of its location from the bottom. So pressure at C and its location from the bottom. Z sub C. Ito. Okay? So, wait lang ha. Okay, so we can continue. So find also the hydrostatic force acting on the gate. So hanapin natin ito, no? Yung Z sub C. Find also the hydrostatic force acting on the gate. So ito yung center of pressure ng ating uh, center of pressure natin, no? Acting on the gate. So ito yon, center of pressure natin. And this is where this is the location of the hydrostatic force. Okay, so that's the location of the hydrostatic force. So we are to determine the hydrostatic force and its location from the bottom. Location yan from the bottom. So kukunin natin yan, ZCP. Okay? So this is our free liquid surface. Okay? Wherein the gauge pressure is 0. No? So required pressure at the centroid, location of the pressure at the centroid, no? The magnitude of the force, magnitude of the hydrostatic force acting on the gate, the location of the hydrostatic force, yung Z sub Cp, no? Okay. So solution, the pressure at the centroid is equals to the unit weight of water multiplied by H sub C, no? The pressure head acting, the pressure head, no? So from the free liquid surface to the centroid of this plane area. Okay? So in that case, so considering the specific weight of the liquid to the left, we consider the specific weight of the liquid, which is water, to be at a temperature of 4 degrees Celsius. So this is an assumption of the temperature because in the problem it was not indicated what is the temperature of water. So this will be the assumption. So then multiply by H sub C. So next, this is H sub C. This is now H sub C. Okay, and again H sub C is the distance from the free liquid surface to the centroid of the plane area. No? So the centroid of the gate. So take note of this distance. Okay, this is, so before we can determine this, take note that this is equals to B. Okay, 1.5 meters. This is our base. Okay, and for our height, we have 3 meters. Okay, this is 3 meters for the height. So if this is 3 meters and this is the centroid, and since this is rectangle, what will be this length? What will be this length if this is rectangle? So that is simply A over 2. Half of A, no? Considering the centroid of the rectangle. If this is 3 meter, this will be 1.5 meter. Okay? So now the pressure at the centroid can be obtained by multiplying the specific weight of water at 4 degrees Celsius multiplied by 2 plus A over 2. So that is equal to HC. No? So 2 plus A over 2 equals HC. Okay? So we have that. So we can now proceed. So we can substitute. So we have 9.81 kilonewton per cubic meter as the specific weight of water at 4 degrees Celsius multiplied by 2 plus 3 over 2. So A is 3 meters, right? A is 3 meters. 2 here is in meter also. So they have the same unit. So I can put parenthesis, then write the unit to the right. So 2 meter plus 3 meter over 2, or simply 2 plus 3 over 2 meters, right? So to make things simple, no? So we have now P sub C, the pressure at the centroid, is equals to 34.34 kilopascal. So we have kilonewton per cubic meter times meter, that is kilopascal. Okay? Or you can be specific, no? The pressure at C is 34.34 kilopascal gauge, no? So either, no, is acceptable, no? So that's it. So we can proceed. So we have Z sub C. We're looking for Z sub C, right? So that we can able to cite the location, no, of the centroid, no, from the bottom of the gate. So this is, so the centroid, from the bottom to the centroid, since this is rectangle, this is also A over 2. This is also A over 2, right? Where A over 2 plus A over 2 becomes A. So we have now 1.5 meter. Okay? So Z sub C is 1.5 meter. So we can now finalize. So the pressure acting at the centroid of one side of the gate is located 1.5 meter from the bottom of the gate. No. So that is our answer. So the pressure acting at the centroid of one side of the gate is located 1.5 meter, okay, from the bottom of the gate. Okay, so we can now proceed. So next, we are to determine the hydrostatic force and the location of the hydrostatic force from the bottom of the gate. So we have the formula for the force for the hydrostatic force is equal to the pressure of the centroid multiplied by the area of the rectangle. And in this case, consider this area. And we have now the pressure at the centroid multiplied by, so the area of the rectangle is simply BA, right? Length times width. So we have now the pressure at C that was obtained in the previous slide. So 34.34 kilopascal gauge, that is kilonewton per square meter, no? And multiplied by B, which is 1.5 meter, and A, which is 3 meter. Okay? And will give us an answer of 154.5 kilonewtons. Next, we consider this one, okay? The eccentricity, the distance between the centroid and the center of pressure. So we consider the eccentricity. So this is a solution so that we can able to determine the location of the hydrostatic force from the bottom of the gate. So E can be obtained using the formula, the moment of inertia about the xc axis, no, all over the the height between the free liquid surface and the centroid multiplied by the area of the plane area, the area of this plane surface, okay, which is a rectangle. So the eccentricity is now equal to, so as I have discussed earlier, no, in my previous slide, I'm encouraging you to memorize that the moment of inertia of a rectangle about the xc axis is equals to 1 over 12 BAQ. No? 1 over 12 BAQ. Then HC is what? HC is 2 plus A over 2, right? HC is 2 plus A over 2. Then multiply by the area of the rectangle, which is BA. Okay? So this is now, so we can able to eliminate B and B. Then 3 and this is 1, so it becomes, we can eliminate 1A, so it becomes A squared. No? That's why 1 over 12 A squared. Then this will remain 2 plus A over 2. Okay? And then we have now, so A is 3 meters, so 3 squared over 12 square meter, no? So this is actually 3 meters squared, no? So we can write this as 3 squared square meter, or 9 square meter, and that is 9 square meter, right? So we can proceed. So our answer is 0.2143 meters. 0.2143 meter. Okay? And we can now find, so this is E. We can now find for ZCP because we have E and we have ZC. So this is the total length, ZC, which is 1.5 meter, right? This is 3 over 2 meter, right? 1.5 minus the eccentricity will give us the distance between the hydrostatic force and the, so between the center of pressure and the bottom of the gate, no, which is CCP, no. So we'll solve for that vertical distance. So we have 1.5 meter minus the eccentricity will give us 1.286 meter. Okay? 1.286 meter. And we can now finalize our answer. So the hydrostatic force acting at the center of pressure of one side of the gate, no, is located 1.286 meter from the bottom of the gate. No? So that is our answer. So I hope you get it. No? So we can now proceed with our next problem. So we have problem number 2. So gate AB in the figure is 4 feet wide and is hinged at A. Gauge G reads negative 2.17 psi and oil of specific gravity 0.750 is in the right hand tank. So what horizontal force must be applied at B for equilibrium of gate AB? So let us analyze the problem now. So we have here gate AB, okay, and for gate AB, so we have this the right side view of the gate, okay, the right side view of the gate, okay. This is the front view of the gate, okay. So considering the right side view, okay, this dimension is 4 feet, okay. This dimension is 4 feet. So alam kasi natin yung gate ay meron siyang third dimension, right? So itong dimension na yan, okay. So ito yung area na concern natin. So ito yung area, no? And ito ay 4 feet. Ito yung 4 feet. Okay, ito yan. Okay? So yung kanyang right side view. So in this case, it is hinged at A, no? So it is hinged at A. So at A, it is hinged. So meaning, uh, meron siyang support sa A, no? Na kung saan ang hinge na to, uh, sinusupport niya yung point A. Okay, para fix siya, no? Para ma-fix. Okay? So kumbaga fixed 'yan at saka yung tapos yung B, yung remaining part free to move siya, no? Para siyang pintuan na kung saan yung yung part na to ay naka-hinged. So ibig sabihin, uh, we can open it, we can close it, no? So ibig sabihin na it can swing back and forth. So depende kung saan mas malakas ang puwersa. No, it can swing back and forth. Okay? So it is hinged at A. So ang purpose niyan para mag-swing, no? Para may chance na mag-swing yung ating gate, no? So we have here gauge G reads negative 2.17 psi, no? So ito yung ating gauge meter. Okay? Ang reading ng ating gauge meter dito sa part na to ay negative 2.17 psi. Okay? So ito yung measurement ng air sa loob, no, ng tank. Ito ay isang closed tank. Okay? So at mapapansin nyo, it's negative 2.17 psi. It's below zero gauge pressure. Sabihin niyan, pag below zero gauge pressure, below atmospheric pressure, no? So in this case, no, vacuum, no? Vacuum yung nandito. Kasi sabi natin na itong part na to ay vacuum. Okay? So ibig sabihin niyan, little amount of air, little particles of air is inside, no? Perfect vacuum 'yan kapag negative 14.7 psi. So perfect vacuum. 100% no air particles. Kaya lang hindi siya perfect, negative 2.17 psi lang. Okay, so sabihin niyan, may natitirang air particles dito, no? So ganun siya. So in this case, we have oil. On the right hand tank, we have oil, no? Wherein the specific gravity of oil is 0.750. Okay? So the question now is what horizontal force must be applied at B, no? For equilibrium of gate AB. So para in equilibrium condition yung ating gate, ano ang ating i-apply na force sa point B, no? Para hindi para maging at rest yung ating gate, no? So in equilibrium. Okay? So ano ang ating force na i-apply? No? So this is just an assumption of the direction of the force. No? Ito yung assumption natin sa direction ng force. So kasi alam kasi natin this is water at mapapansin nyo ang taas ng level. So sabihin para masasabi natin na mapuwersa yung tubig. No? Mapuwersa yung tubig para lumabas dito sa gate. No? Tapos yung oil matatapon, no? Yung oil matatapon. Okay? Ngayon, ang question ng problem, ano ang force na i-apply natin sa B para mapanatili yung ganitong posisyon ng gate? Hindi siya gagalaw. Okay? Ibig sabihin, lahat ng pwersa sa right and left sums up to 0. No? So, sabihin, pantay yung forces sa right tsaka sa left. Para magpantay, ito yung aking assumption, to the left ang force natin, applied at B. Dahil hindi naman talaga natin alam yung actual na puwersa. Baka mas mataas yung puwersa ng oil kaysa sa puwersa ng tubig. So, this is my assumption now that the direction of the force must be applied is toward the left. No? Toward the left. So this is the force applied at B. Okay? Now, if we apply this force, gate AB will now be in equilibrium. No? If we apply this force. Okay? So what force should be applied at B so that the gate will be in equilibrium? No? Solution to the problem, for the gate to be in equilibrium, no, para maging at rest yung ating gate. Tandaan nyo pag equilibrium, there are two conditions. Either the body is at rest or the body is in constant velocity. Okay? Two conditions for equilibrium. The body is at rest or the body is at constant velocity. Recall natin yung Newton's first law of motion. So, ganun yung sa Newton's first law of motion. No? So, the condition for equilibrium is a body is at rest or the body is in constant velocity. Okay? So, in this case, gate AB to be in equilibrium, the sum of all forces acting on the gate must be equal to 0. So, in-apply natin yung Newton's first law of motion. Nanggaling ito sa Newton's first law of motion. Okay? The law of inertia. Okay? The law of inertia. So, for Newton's first law of motion, so upon applying, the sum of all forces acting on the gate must be equal to 0. So, pagka equal to 0, yung sum of all forces acting on the gate, no, masasabi natin na in equilibrium ang ating gate. No? So, ibig sabihin yung summation forces horizontal is 0. Okay? Pagka ito ay nasatisfy, the body is in equilibrium. The body is in equilibrium. Sabihin yan, forces to the right minus forces to the left, no? Okay? must be equal to 0, no? Force applied to the right minus forces applied to the left must be equal to 0, no? All forces, no? Summation of all forces to the right minus summation of all forces to the left must be equal to 0, no? Alright, so, or, the other way around, the sum of all moments about any point on the gate must be equal to 0, no? So, another condition for equilibrium, aside sa sum of all forces acting on the gate must be equal to 0, the sum of all moments about any point on the gate must be equal to 0. No? Ibig sabihin yan, pag nag-moment ako sa A, no, dapat ang makuha kong sagot ay 0. Okay? Ibig sabihin yan, pag nag-0, in equilibrium yung ating gate. No? Kasi kapag hindi ito 0, magtitwist yung gate. No? Magtitwist siya. No? Either to the right or to the left pag hindi 0 yung ating moment. No? Kasi ano siya eh, naka-hinge dito, tapos yung sa B, free to move siya. So, free to move yung ating gate. No? Okay. So, dahil free to move siya, masasabi lang natin na nasa equilibrium to, no? Kapag ang summation moment at A equals to 0, no? Or pwede rin ako summation moment at B equal to 0. Pwede rin yan, no? Or kahit saang part ng gate, no? Kahit saang part ng gate. Okay? Dapat masatisfy ang condition ng summation moment equals to 0. Aside dito, sum of all forces acting on the gate must be equal to 0. Ibig sabihin, gate AB is in equilibrium pag yung dalawa na satisfy. No? So, ibig sabihin yan, let's say, halimbawa, ito lang yung nasatisfy, yung summation moment equals 0, automatic satisfied na rin yung sum of all forces acting on the gate must be equal to 0. Okay? Okay, so we can proceed. Now, for the next step, we now consider horizontal forces acting on the gate, no? Except at point A, no? We consider horizontal forces acting on the gate except at point A. Kasi nakahinge siya dito. Pag magmo-moment ako sa A, hindi ko isasama yung mga forces acting at A. No? Hindi ko sasama. So therefore, disregard ko yung forces acting at A. Okay, so in this case, this is our gate. And one of the forces acting on the gate is the force applied at B with this assumed direction to the left. Another force acting on the gate is the force due to water. So this force due to water is the hydrostatic force due to water. Another hydrostatic force is the hydrostatic force due to oil. No? Hydrostatic force due to oil. Okay? So acting to the left. No? Force due to water acting to the right. No? Next step, we can take moment at A now equal to 0. No? So we already considered all the forces acting on the gate. We had identified, no, 3 except at A. No? We had identified 3 forces acting on the gate except at A. So the hydrostatic force due to water, the hydrostatic force due to oil, and the force that must be applied at B, so that the gate will be in equilibrium. Now, we consider this part wherein the gate is hinged. And from that part, we consider this vertical distance from point A to the force, the hydrostatic force due to oil, no? Because when you take moment, we will also consider the distances, no? The the distances that are perpendicular to the forces. Okay? So this force, no? So considering this force FO, this is now this distance is considered because we know that the hydrostatic force is acting at the center of pressure. So this is the center of pressure with respect to oil. No? This is the center of pressure where the hydrostatic force due to oil is acting. No? So therefore, if this is the center of pressure for oil, no, this is now the distance, no, ZCP for oil, no, ZCP for oil. Okay. Now another consideration is this distance, okay, which is ZCPW. ZCPW. So this is the center of pressure, no, with respect to water. With respect to water, this is the center of pressure. Okay? And since this is the center of pressure, we consider this vertical distance as ZCP sub W. No? Z sub CP sub W. Okay? For the vertical distance. Okay? Alright, so we now proceed. So another consideration. So since this is the force FB and we are to take moment at A, we need to find the vertical distance from A to B. And that vertical distance is 6 feet as indicated in the problem. No? This is 6 feet. Since this is oil, which is the same as the height of the gate, which is 6 feet, no? The height of the gate, which is 6 feet, no? Alright, so in that case, we take summation moment now equal to 0, considering clockwise direction for the moments as positive. Okay, we consider the clockwise direction for the moments as positive. Okay, so if I'm not mistaken, you have encountered this in engineering mechanics, the mechanics of um, rigid bodies, no? Mechanics of rigid bodies or engineering mechanics. So this was taught to you, no? So that's my assumption that this was discussed. Okay, so I considered clockwise direction as positive. It's up to you. If you want to consider counterclockwise direction as positive, you will arrive with the same answer. So in this case, I consider the clockwise direction as positive. And we start with the FO, okay, FO multiplied by ZCPO for that moment. When we multiply FO by ZCPO, so that is already our moment, okay? So moment, and then take note that it has a positive sign. Why positive sign? Because the direction, no? the direction of the potential twist is like this, right? The direction of the twist of the gate, no? So the direction of the twist of the gate, no? If we consider FO only, will be clockwise, right? It will be clockwise. This is clockwise direction, right? So this is the direction clockwise. That's why it has a positive sign. Then we consider FW, force due to water, the hydrostatic force due to water. And this is the distance. Considering only force due to water, the direction of rotation of the gate will be like this, right? It will be twisted like this if we only consider force due to water. And with that, the direction of the moment, no, is what? The direction is counterclockwise, right? Counterclockwise. So this is counterclockwise. That's why it was given negative sign, because we only consider clockwise direction as positive. Therefore, if it is counterclockwise, it will have a negative sign. Next, we consider the force to be applied at B. And as you notice, this is, we take moment at A. So the gate will be twisted like this. Okay? So with that, this direction is clockwise, right? This direction is clockwise. That's why it has a positive sign. Okay? So we multiply 6 by FB. No? 6 by FB. So that's it. No? So we shall continue now. So the force at B, okay, is now equal to, so we arrange, no? We transpose this to the right, transpose this to the right, given the sign will change to negative, same as FWZCPW, the sign will become positive and transposed. Then we divide it by 6, okay? So then we'll arrive with what answer? Okay, considering this. All right. We don't have yet force due to water. We need to find it. We need also to find and also oil, force due to oil, and this distance as well. We need to find for unknowns, okay, so that we can able to find f sub b. So we start with finding force due to water. So upon to start, we consider uh, water acting on the gate, no? So for water alone in contact with the gate, no? For water alone in contact with the gate. So we disregard oil on the right hand tank. So this is now the illustration. As you can see, we have only water that is acting on the gate, and there's no oil on the right hand tank. No, there's no oil on the right side of the gate. Okay, so this is the solution, no, that we can do to find the force due to water, no. So in this case, so we consider the center of the centroid of the gate, and also the center of pressure due to water. Okay, the center of pressure due to water. So this is the center of pressure wherein the force due to water is acting at, no? The force due to water is acting at. And recall that The hydrostatic force is equal to the specific weight of the substance multiplied by h sub c, which is the distance between the free liquid surface to the centroid of a certain body, okay, multiplied by the area, no? So with that, we have the substance as water, okay, Fw is now equal to the specific weight of water at 4 degrees Celsius. So this is our assumption of the temperature of water to be at 4 degrees Celsius. Okay? And HCW, because our substance is water, then we have the area. So this is the unit, we consider the unit weight of water at 4 degrees Celsius. And take note that the pressure at the gauge pressure measurement at this position, no, measuring the gauge pressure of air is negative 2.17 psi, which is the pressure at the interface of water to air, no. So this is the pressure at the interface of water to air, no, water to air interface. Okay, so this one, okay, so which is measured to be negative 2.17 pounds per square inch. Now, in order to apply this formula, no, F equals specific weight HCA, there's a condition to be satisfied. The condition is that we should locate the free liquid surface wherein the gauge pressure is 0. We should able to locate to determine the gauge pressure of 0 of the free liquid surface. Okay? So in this case, no, there's no actual free liquid surface. Instead, it is imaginary, no, because this is the actual free liquid surface here, right? This is the actual. Okay? This is the actual free liquid surface. But we have to locate 0 gauge pressure. This is negative 2.17 psi, the gauge pressure, no, at the interface of water to air. Okay, take note, since this is gas, no, the pressure at any point, okay, the pressure at any point in this region is negative 2.17 psi. Okay, and at the interface now, this is negative 2.17 psi. And take note, upon reaching the bottom, okay, upon going down, okay, the pressure will intensify. The pressure will increase until there will be a time that the measurement of the pressure will become 0. And that is now what we call as the imaginary liquid surface. No? Imaginary liquid surface. Okay? Imaginary free liquid surface. So, in this case, at this point, no, this is now the pressure equal to 0, because as we go down, the pressure will increase. So from negative, there will come a time that it will become 0. And this is now our imaginary free liquid surface. Imaginary free liquid surface wherein the pressure is 0. So we consider this the centroid of the gate. Okay, and this is now the height, no, or the distance between the imaginary free liquid surface and the centroid of the gate, which we call HCW. So this is HCW, no? So this is HCW. So this is our interest. This is our concern to determine this value. Okay? But how can we determine? Alright, so before we can determine that, we should consider the distance from the water to air interface and up to a point up to the imaginary free liquid surface. No? So we have the actual free liquid surface, the distance between the actual free liquid surface and the imaginary free liquid surface. No? The water to air interface. Okay? So we consider this distance. Let's call it x. Okay, let's call it x. Now, considering the distance from the bottom of the gate up to the centroid of the gate, okay, this is a over 2. Why is it a over 2? Because our gate is a rectangle, right? So this is the right side view of the gate, and it is a rectangle. And take note, since it is a rectangle, okay, as I have discussed, okay, it is the centroid location. So this is a over 2. Okay, for the centroid location, this is a over 2. That's why we have a over 2. Okay, and with that, this is 4 feet equals to B. Okay, this is A. Okay, this is A. And that A value is this one, 6 feet. Right? So A is 6. Therefore, 6 over 2 is 3. So this is 3 feet. Okay? So this is 6 feet. So this will become 3 feet. A over 2. No? So dimensions of the rectangular area. No? So next, we can now determine HCW. Okay? Take note that if we sum the three, no, x plus HCW plus a over 2, the sum will become 18. 18 feet, right? That will become 18 feet, right? The sum of the three is 18 feet. Okay? So, with that, HCW now is equals to 18 minus x minus a over 2. That's why we have this one. Okay? So we now proceed. So recall that the pressure, no, the pressure at the bottom is equal to the pressure at the top plus the specific weight of the homogeneous liquid multiplied by the height, no? So this was discussed before, so we will apply it in this problem. So in that case, in order to solve for x, we apply we will apply this formula, no? In other words, the pressure at the bottom here, okay, pressure P2, which is a greater pressure, so that will be P. P1 is a lesser pressure. That is negative 2.17. Water to air interface. Then the liquid substance is water between the water to air interface and the imaginary free liquid surface. No? So that's why we consider it to be water and it is at 4 degrees Celsius. Then H here refers to the distance between the water to air interface and the imaginary free liquid surface, which is x. So H now becomes x. Okay? So therefore, we can solve for x. So that is P minus PWA all over this one. Okay? So that we can able to solve for x. Okay? So we have now x, zero pressure, okay, minus pressure, water to air interface, okay, water to air interface, that is negative 2.17 psi, that is pounds per square inch, okay, and then we convert square inch to square foot, okay, so that we can able to cancel some units below, okay. So in this case, for every 144 square inch, that is 1 square foot. Because 12 inch squared is 1 foot square, right? It's 1 foot squared. 1 foot is 12 inches. So therefore, 12 inch squared is 144 square inches over square foot. No? Okay? And then, we have the unit weight of water at 4 degrees Celsius. Since this is in PSI, pound per square inch, so we will use 62.4 pound per cubic foot. English unit. It is an English unit, right? So, pound per cubic foot, 62.4. Okay? So, this will be eliminated. Pound will be eliminated. So, cubic foot over square foot. Now, this will rise. This will be in the numerator. So, feet cube over feet squared. So, the unit will be feet. No? For our answer for x. So, x now is 5.01 feet. Okay. So, we can now substitute the unit weight of water is 62.4 pound per cubic foot. Then 18 minus x is 5.01 feet. A is 6 feet, no? So since they all have the same unit, okay, that's why I just factor out the unit, okay, 18 minus 5.01 minus 6 over 2 feet. Then the dimension B is 4 feet, dimension A is 6 feet for the rectangular, for the rectangular gate, no? Okay. So we will now have an answer of 14,961.024 pounds. Okay, so this will cancel. Okay, so we have that answer, or this is 15.0 times 10 to the 3 pounds. Okay, 15 point, considering three significant figures, this is 15.0 times 10 to the 3 pounds. Diba? 14.961. So, sabihin yan, kung 4 significant, 14.96. Kung 3 significant, 15.0 na siya. Okay? Times 10 to the 3 pounds. Familiar naman kayo sa significant figures, right? And then, take note that this is equals to 15.0. Keep Take note that 1 kip is equals to 1,000 pounds. Sabihin niyan, 1 kilo pound. Diba? 1,000 is kilo. 1 kilo pound. Sabihin niyan, 1 kip is 1 kilo pound. So, 15.0 kip, KIP. Or kips. Dahil marami, no? So, next we have we have now this one. Our next target is to determine, okay, we're done with that, to determine ZCPW, the location, okay, ZCPW. So this one, no, the distance ZCPW, no, the distance ZCPW. So we're going to find that, no. So we consider, this is ZCPW, okay, and how do we find this one? So to find that, we need to determine the eccentricity. Okay, we need to determine the eccentricity, the distance between the centroid of the gate and the center of pressure, no, due to water. Aside from the eccentricity, we need to find for this distance from the top of the gate, which is at A, and down to the centroid of the gate. And of course, since it is a rectangular gate, this will be A over 2, right? Next, so ZCPW, no, is now equal to the sum of the two. A over 2 plus A is equals to the distance ZCPW. So that is the distance from the hinge at A to the center of pressure, no, due to water. So in that case, the eccentricity can be obtained by the formula IXC over HCW times A. No? So that is the formula for the eccentricity. Alright. So how do we determine? Do we have IXC? IXC is the moment of inertia of the rectangle with respect to XC axis, no? Where that XC axis passes through the centroid of the rectangular area, no? So we have now this one. The moment of inertia of the rectangular gate, no, of this area, this surface, is 1 over 12 BA cubed. Okay? And then HCW, that is 18 minus X minus A over 2. This one. Then the area of the gate is BA. Base times the height, no? Or length times the width, or width times the length. Okay? So then, this is, we ended up here. So we will now determine ZCPW. So to determine ZCPW, so since this is A, so that is 6 feet, okay, over 2 plus 1 over 12, B is 4, okay, and then A is 6, so 4, 6 cubed. So this is 4 feet, 6 feet. So feet and feet cube, no? Feet to the fourth. Okay, kasi feet cube is feet cube times feet to the fourth. Okay. So yan ang unit ng moment of inertia. Naka-raise siya to the fourth power. No? All over 18 minus 5.01 minus 6 over 2 feet. B is 4 feet. A is 6 feet. Okay, and we will obtain an answer of 3.30 feet. Okay, so we're done with FW and ZCPW. Two more to go. Okay, before we can find FB. Okay, so this is for FB. Now, for oil alone in contact with the gate, we shall now consider. Okay, for oil alone in contact with the gate. Now, since this is the gate, no, and we have 6 feet of oil, so in this case, we disregard the left-hand tank, which is liquid water. Okay, and this is now the centroid of the gate and the center of pressure due to oil. Okay, and this is where the hydrostatic force due to oil is acting. And recall that the hydrostatic force is equals to this formula, and we will convert it in terms of oil. So force due to oil equals to unit weight of oil, HCO times area. Okay, so in this case, this distance, take note, is HCO. Okay, so that is HCO. Take note that HCO is the distance between the free liquid surface down to the centroid of the gate. And also, take note that the specific weight of oil, as I have discussed before, that the specific gravity formula is the unit weight of the substance over unit weight of water at 4 degrees Celsius. And the specific weight of the substance is the specific gravity of the substance multiplied by the unit weight of water at 4 degrees Celsius. That's why it becomes, so our substance is oil, so we have this now. Okay, so that is now our formula. Okay, so and then we have HCO as A over 2 equals sa A over 2 because the gate is rectangular, therefore A over 2, A over 2, no? So it is equals to A over 2. And then the area of the gate is BA. So the force due to oil 0.750, okay, 62.4, then 6, then 6 over 2, 4 feet, 4 feet, 4 feet, 6 feet. So we will have an answer of 3369.6 pounds or 3.37 kilopounds. Okay, so that is our answer for the force due to oil. So we're done with the 3. one more to go before we can find FP. Now, for ZCPO, this is ZCPO. Okay? So, what is the force? Sorry, the distance. What is this distance? So, we consider the eccentricity. Okay? We consider the eccentricity due to oil. Okay? And we have now eccentricity due to oil plus HCO will give us ZCPO. Okay? So that is A over 2 plus IXC HCO multiplied by the area. Okay, so I'll be specific, no? So this is E sub O, no? So this is E sub O, no? So this is E sub O for oil. Okay? Eccentricity due to oil. Okay? Now we have so A over 2 plus IXC over HCO times the area. So this is the formula for the eccentricity. Okay? So this is now A over 2 plus 1 over 12 BA cubed. Okay? And then for HCO, we have A over 2. Okay? And then for the area, we have BA. So ZCPO now is equals to 6 feet over 2 plus 1 over 12 for 6 cubed feet to the fourth over 6 feet over 2 times 4 feet times 6 feet. And we will get an answer of 4 feet. So actually, there's a shortcut for finding ZCPO. Again, since this is rectangular, this is our pressure diagram. Okay, so this is our pressure diagram. So the pressure intensify as we go down. The pressure intensify. And since this is triangle, from the apex of the triangle up to this point is the location of the centroid of this triangle, which is the center of pressure. Okay, the center of pressure. So with that, that is two-third of the total height, no? Two-third of A, no? So this is two-third of A. So what is two-third of A? Two-third of 6, because A is 6 feet, right? 6 over 3 is 2 times 2 is 4. So that is 4 feet. That's why this is only true, no? If the gate and the oil are at the same level. Okay? If they are at the same level, that is true. Okay? So that is the answer. So we have now 15.0. So this is ZCPO. And FB is equals to, so kompleto na. Meron na tayong FW, ZCPW, FO, ZCPO, FW, ito, ZCPW, ito, FO, ito, ZCPO, ito. So, ang unit ng 15.0 tsaka 3.37 is keep. 3.34 tsaka unit nila ay feet, no? So, meron kang keep feet. Okay? Pinactor out ko na para isahan na lang. All over 6 feet for all over 6 feet. Itong 6 na to, okay, ay 6 feet actually, no? 6 feet times FB, di ba? 6 feet times FB. Ito. Yung 6 na yan, merong unit na feet. Okay? Kaya makakancel yung feet. Okay? At magiging keep. So, we have 6 keeps. Okay? So, that is our answer. So, that's the force to be applied at B so that it will be, so that the gate AB will be in equilibrium. Okay? So that ends my presentation. Alright, so ito siya, no? FB, 6 skips. So that it will be, the gate will be in equilibrium. At take note, positive yung sagot. Pag positive, ibig sabihin, tama yung assumed direction natin. To the left. Tama. Kasi pag nag-negative, yung sagot dito, sabihin yung actual direction to the right. Actual direction to the right. Pag nag-negative yung sagot natin dyan. Kaya lang dahil positive, sabihin tama yung direction. No? Tama yung direction. So, ito kasi yung magnitude ng force. Ang magnitude ng force ay positive. Sabihin, tama ang direction. Pag ang magnitude na nakuha natin ay negative, sabihin, yung actual direction ay to the right. Okay? So, in this case, to the left, dahil positive naman yung nakuha nating sagot. Alright, that ends my presentation. Alright, good day everyone.